Okay, let's continue on looking at stationary points. We'll look at example 12. So first thing we want to do is differentiate. So I'll say that dy by dx is equal to 12x squared minus 8x cubed. So let's go ahead and find our stationary points. Remember that stationary points occur when dy by dx is equal to 0. So that will give me 12x squared minus 8x cubed is equal to 0. Okay, so let's factorise. Let's take out a common factor of 4x squared. So that will be in brackets 3 minus 2x is equal to 0. So that gives us x is equal to 0, or x is equal to 3 over 2. Okay. Let's put these values back into the original equation. So let's put 0 in, first of all. So I'll say when x is equal to 0, y, looking at that, it would just give us y is equal to 0. Let's go for when x is equal to 3/2. Y is equal to 4 times 3/2 cubed. Take away 2 times 3/2 to the power 4. Okay. So that's going to give us 108 over 8. Take away 162 over 16. Okay. And simplify that. Let me just do it on my calculator quickly. So 108 over 8, take away 162 over 16, which gives us 27 over 8. So my two coordinates are 0, 0 and 3/2, 27/8. Let's go ahead and create our nature table. So we're going to be approaching the first stationary point, which is 0. We're going to be approaching the second stationary point, which is 3 over 2. And then leaving that. Put in our dy by dx. And then the shape. Okay, so if I put 0 into my differential, then I'm just going to get 0. If I put 3/2 in, I'm just going to get 0, because that's what we found originally. So let me pick values that are before, between, and after the stationary points. So I think I'll go for -1 here. I'll go for 1 here. I'll go for 2 here. So if I put -1 into my derivative, I'm going to get 12 times -1 squared, so it's going to be 12, plus 8, which is going to be 20, so it's going to be positive. If I put 1 in, I'm going to get 12, take away 8, which is 4, which is also positive. If I put 2 in, I'm going to get 12 times 4, which is 48. Take away 8 times 8, which is 64, so that's going to be negative. So my shape is going to be up, along, and down. So I have, if it's up, along, up, it's a rising point of inflection. I'll just say rising pi at 0, 0. And then it's up, along, down, so it's a maximum turning point at 3/2, 27/8. So that's stationary points and their nature.